Here's an example for graphing on delta math. You're going to do everything the exact same. So first, if you can factor anything, I would do that. So I get 5 times x plus 2 on top. Can't factor anything on the bottom, so I'll leave it as 3x minus 4. So first for your domain, set that denominator equal to 0, and you get x equals 4/3. That's your only domain issue. That's kind of nice. So negative infinity to 4/3, and then 4/3 until infinity. So that 4/3, that 3x minus 4 never cancels. So that means that that was a vertical asymptote. And we don't have anything to cancel, so there is no hole in this problem. So that's a very nice start there. X-intercept, we set the numerator equal to 0. So x minus 2 equals 0 means you have 0, comma, negative 2. If you have 5 equaling 0, which you should check, well, 5 can never equal 0, so there's no other x-intercept. So make sure you check that, though. If that had been 5x, then you would have another x-intercept there. The y-intercept is when you plug in 0. Again, I recommend doing that in the original problem. You get 10 over negative 4, which is negative 5 halves. So 0, comma, negative 5 halves. Oops, I messed up the x-intercept. I wrote that backwards. Negative 2, comma, 0. Negative 5 halves we'll look at later is negative 2.5 when we plot this. Horizontal asymptote is all that's left then, and for that, again, we use our long division. So 5x plus 10 goes on the inside, 3x minus 4 goes on the outside. We do 3x times what would give you 5x. So this is a little bit tricky. You'd have to do 5 over 3, because 5 times 3 would give you 15 divided by 3 gives you right back to 5. So this is going to be some pretty nasty math here. The trick here is that if the numerator and denominator have the same degree, the same exponent for the biggest exponent, all you have to do, really, is look at the numbers in front. 5/3 is going to give you your answer to the long division. So if you were to multiply that through, you would get the 5x, and this would become, 20 over 3. You would subtract those values, and that would cancel out. You'd be left with whatever 10 plus 20/3 is would be your remainder over the 3x minus 4. The issue is, for crossing the asymptote, is when the remainder equals 0. Well, this remainder is just some number. So it's never going to equal 0. So we're never going to cross. Our horizontal asymptote is still going to be that value out in front. Y equals 5 over 3. So on a lot of these, we won't even have to worry about doing anything crazy with when you might cross that horizontal asymptote. But we're going to go one step at a time. So our x-intercept, if I click x-intercept, it's at negative 2, comma 0, so I'll drag it over. We had our y-intercept at negative 5 halves. That's negative 2.5. We'll get it as close as we can down there. Our vertical asymptote happened at 4 over 3, so a little more than 1. Our horizontal asymptote happens at 5 over 3, so a little bit between 1 and 2, a little bit closer to 2. And there is no hole. So that's all we have to do. So now if we were drawing this ourselves, we'd connect these two dots to make it curve downwards, and then the portion to the right for the other side of our domain here, we need to have a part on the right-hand side of that vertical asymptote. It's either going to be above or below. If it's below, it would hit that axis again, so it'd have to be above. And when we click plot rational function, that's exactly where it would show up. So we have what we want to find. Click submit answer. Yes, I'm ready to submit, and there you go. And again, it gives you all of the information we just went through to make sure you have done it properly. There you have it.